Hi all, this video is about PSPICE simulation of RC transients. My name is Prashant Kumar Suri. This is my email ID. So we'll solve this problem using PSPICE simulation software. There is an 8 microfarad capacitor that is in series with a resistor whose value is 0.5 mega ohm, and it is connected to a DC voltage source of 200 volts. The first part of the question is time constant tau is asked. Okay, you already know the formula for tau. Tau is product of R and C. So here R value is 0.5 mega, 0.5 into 10 to the power of 6. C value is 8 micro, that means 8 into 10 to the power of minus 6. So if you calculate it, you will get this answer as 4 seconds. This is the first part of the question. Second part of the question is, we are required to find the time taken for the voltage across the capacitor to reach 160 volts. Okay, supply voltage is 200 volts and one time constant is 4 seconds. So we'll use PSPICE simulation software. So I've already downloaded PSPICE student version in this my laptop, and first job is to search for PSPICE design manager. So it is here. I'll click this. So this screen will pop up. Then we have to select schematics. This is the schematics. Click that. Then you will get the screen like this. Now we have to pull all the required components. So go to draw. Okay, you can either click draw, get new part. This is one way. Otherwise, it is also here. You can click this icon, get new part. Okay, go to libraries, go to source library. First is the DC voltage source, that is VDC. How do you know that? You can look here. It's a simple DC voltage source. The description of the part will be displayed here. Okay, so click OK, click place and close. You'll get like this. Next component is resistor. Just type R. Okay, you can see here resistor. Place and close. It will come here. I will place it here. Next is capacitor. Click this. Type C. Place and close. Put somewhere here. Now I want to rotate it so that it will appear as exactly how we draw while writing in the paper. So to do that, first you have to highlight it in red. Whenever it is in red, you can rotate it. Okay, so rotate. So I will drag this and I will place it here. Next we need the switch. So get new part. Click libraries. Switch will be in eval. You have to click here. Scroll down. Scroll down. So you can see here SW_T close. That is the switch. Okay, so place and close. Close it. Okay, next we need analog ground. Okay, so go to libraries, port AGND means analog ground. You can see here. Okay, click OK, click place and close, place it somewhere here. Okay, so we have gathered all the required components. Now we have to wire it. So this is the wiring symbol, draw wire. Okay, click that. Okay, so connect the circuit like this, like this, like this, like this, like this, like this. So now we have drawn the circuit. Now we have to mention all the values. So the voltage value given in this circuit is 200 volts. You can just type 200, or you can type 200 V. V means volts. Save attributes. Okay. Next, resistance value given in this circuit is 0.5 mega. In PSPICE, mega is written as MEG. Okay, there is no space. Please note it. You should not give any space. Save attributes. Okay. Then capacitor is the energy storing element. You should be very careful. its capacitance value in this question is 8 micro. Micro is denoted as U. Okay, and in the energy storing elements, you must mention the initial condition. Initial condition means capacitor is initially uncharged. So voltage across the capacitor initially it is 0 volts. You can just type 0 or you can type 0V. Both are okay. Okay. Now I want to observe the waveform. We are interested in voltage across the capacitor. So you can click this voltage marker, place it here. Okay, so that means voltage across the capacitor waveform will be displayed. So once you complete the circuit and circuit values, you have to tell the PSPICE compiler what type of analysis it has to perform. So click analysis, click setup. We need transient analysis, click transient. Okay, so print step is 0. So we have already found one time constant in the section A of this problem. We have got it as 4 seconds. And I will run the simulation for 8 time constants. I will tell you why I am running for 8 time constant. So 8 time constant will be 32 seconds, right? So 32s, or simply write 32. By default, it takes the time as seconds. Okay. Click close. Now you need to save this simulation first. Okay, I'll give the name as transient problem 1. Okay, save it. So now it is ready for simulation. You have to tell the PSPICE compiler to simulate. So there are two ways to do so. One is you can click analysis and you can click simulate. This is one way. Second way is here already there is icon simulate. Okay, you can see here. I will zoom in. If you want to zoom out the circuit, you can use the zoom area. So this is the build circuit. Okay, so this is the simulate. So I am simulating it. So these are the voltage values and it will go to the probe. You look here, this is the voltage across the capacitor waveform because we have put the voltage marker across the capacitor. Therefore, it displays only the voltage across the capacitor waveform. Now, the question asked is how much time it takes for the capacitor to reach 160 volts, right? So to find that, I will take the trace. Okay, we'll select the cursor and click display. Okay, now your eye should be here. This should be 160 volts. Okay, you can see the cursor here. Okay, so when I move this, look here, it is moving, cursor is moving, and answer should be 160 volts, right? You have to look here, 160 volts. X-axis is time. Time is in seconds. So 160, now it is 152.383. 157, 159. Now it is 160. You see, 160 volts. So it takes 6.43 seconds. Okay, you can display this answer. You can click this, it will mark. So first one is x-axis. X-axis is 6.43 seconds. Second one is the y-axis. Y-axis is the voltage value, which is 160 volts. So this is the second part of the question. Third part of the question asked is what is the voltage across the capacitor after 5 time constants, right? 1 time constant is 4 seconds. So 5 time constant is 20 seconds, right? 5 times 4. So you have to move the cursor till it is 20 seconds over here. Okay, or you can look here, this is 20 seconds here. Till here you have to move it. See, now it is exactly 20 seconds. I will mark this point. So 20 seconds is the time and capacitor voltage is 198.664 volts. Okay, so if you calculate it analytically using the formula, you will get the same thing. For that you can refer my another video, okay, which I have given. and that will I got the same answer. So if you want to label this, so you can click plot, label, text. I'll give the text as voltage across the capacitor. Okay. So that's it about the PSPICE simulation.